Welcome to, this is part C of title you already know. Analysis means flexural analysis of singly reinforced rectangular section, doubly reinforced rectangular section and T section. In part A and part B, I have given a basic concept. One concept pending there, star mark. I already told, if you respond well, I will take one extra class for that beautiful concept. That is why under reinforced section, we can use either mu equal to cu into A or tu into A. Working test method, you should be careful. Working test method, if you use cu into A, you have to reduce the strength of concrete, reduce the stress in concrete. Limit state, nothing. Reason is very beautiful. Actually, that is the real concept of limit state method. I am still waiting. Okay. Now, make a note. In part A and part B, what I told is common for full. All your singly reinforced section, doubly reinforced section, both rectangular and T section. But now I am deviating. See heading? Flexural analysis of singly reinforced rectangular section by limit state method. Remember, flexural analysis for given, this is for given cross section. Remember, when you, that is cross section is given. Therefore, it is actually means to find ultimate MR of given cross section. Ultimate MR is, you can write if you want, maximum factored BM cross section can resist. Make a note. If you want, make a note. I have no space right here. Ultimate MR of given cross section is, you can tell, ultimate moment of resistance is the maximum factored BM cross section can resist. So that BM is not correspond to working load due to factored load. Okay, now start. I will tell everything I will tell. Just one important information. Usually I record in night time. Today daytime. Little disturbance will be there. But disturbance is what? Some background, some sound will be there. Ignore it. Later I will go for more advanced way. So right now, you have to tolerate it. Not a big issue, I think. My voice is crystal clear, audible. Now, when I give procedure, now see, I am giving procedure for right? What is given now is procedure. Later, you have to simply follow the procedure. That's all. Cross section, you should write all these things. Cross section will be given. And first, sketch the cross section. See, this is not there. This you have to write. First, sketch the cross section. Then, get the value of B, D, AST. B means, I written here, breadth or width of the beam, rectangular section. D means effective depth. AST is cross-sectional area of steel in tension. Now, you can write if you want. I will dictate. Effective depth is distance of centroid of tension steel from extreme compression edge. So, you should know whether BM is sagging or hogging. If it is not given, consider any one. Answer will come same. But usually when you analyze practically, you know sagging or hogging. So, I will take one case of sagging, top extreme compression edge. I told more than 10 times. From here D and X you measured. Okay, one line. Or, if it is hogging BM, AST here. So what you do? If the BM is sagging, you consider AST at the bottom. Hogging means at the top. Now, also mark, centroid of the AST from extreme tension edge is, don't put ICTR like that. Effective cover to tension reinforcement. Effective cover to tension reinforcement. Right. Now write your D equal to overall depth D minus effective cover to tension reinforcement. In case clear cover given, what to do, we will discuss later. Sometimes bars can be given in 2 rows. When I do examples, I will explain it. Okay, 2 or D is the distance from extreme compression edge to centroid of tension steel. That much you remember. Over. Now, see, I written here. Now you will be given what is the grade of concrete and grade of steel. You should write here. when you are asked to perform the analysis, we have the grade of concrete and grade of steel should be given. So based on that one, get the value of FCK, that is characteristic compressive strength of concrete, or you can tell crushing stress on test cube, lab result. For that only, after partial safety factor, you finally got 0.45. No, that all discussed in the regular class. FY, characteristic strength of steel reinforcement. Steel reinforcement, okay. Steel reinforcement. FY. Or you consider yield stress of steel. Okay. You get these two values based on given grade of concrete and given grade of steel. Get those two. Okay, now. First, so therefore, when you solve the question, you write B equal to D equal to AST equal to how much FCK, how much FY. Now, make a note. When you find ultimate MR of the cross section, see, it is moment of resistance. You should write a note here. One note right here. We should know whether cross section is under reinforced, over reinforced. You should know it. So therefore, for deciding whether cross, you should write all these here if you want. Somewhere in the box you have to write information. To decide whether cross section is under reinforced or over reinforced, you should know what is the depth of neutral axis for a balanced section. For that you require XU max by D, red color. So that, see, I told you, equation for XU max by D is given here. This I told you last time. I told this last time. Equation for XU max by D. Okay. So right here, in this equation, E of steel is taken as 2 10 to the power 5 Newton per mm square. So XU max by D depends only on Fy. Now, if your given steel is of grade Fe 250 or Fe 4, that is mild steel, Fe 415 or Fe 500, you need not waste time substituting in the equation. Why? Because IS code has given for these three values of Fy, what is XU max by D? Of course, they rounded to second decimal. Okay, done. See, there are so many approximation here. In RCC or steel, approximation. So, there will be slight fluctuation in the result. Engineering mechanics, strength of material, structure analysis, no fluctuation. If I tell answer is 11.884, it is 11.884 only. I will prove it is not even 885 if situation comes. But here, what happens is, later when you substitute, one expression will come MR 21.88, other may give 21.79. Okay, both are same, you can tell. So therefore, approximations are there, second decimal sufficient. Now, make a note, class, right here. Suppose the given value of Fy is other than these three, then use this equation and get the value of XU max by D in the beginning only. That is, as soon as you write Fy value, you see examples coming up. As soon as you write Fy value, write immediately, for which either from IS code or by expression, get the value of XU max by D. Okay, that you write here. Since we are calculating, sometime it may come very nearly same, or second decimal may repeat. Suppose you get some other number, 0.4808. You write 0.48. So therefore, in such cases, when you calculate, you increase the decimal accuracy to third decimal. Right? You make a note here, third decimal. Okay. Then, one more note here. We are going to find ultimate MR. So, already told, it is very important to decide whether cross section is under reinforced or over reinforced. Okay, leave it now. Then, first, location of neutral axis for given section. Remember, I told you, for given section, this is not your what? XU max, given section. That is called XU. So, XU is depth of neutral axis for given section. Once again I am telling, given section from extreme compression edge. equating resultant compression force Cu to tension force Tu, you get 0.36 FCK BXU equal to 0.87 FYAST. See, when I writing here, I never look anywhere. I wrote, see, 0.36 FCK average stress into B into XU compression area, that will be equal to 0.87 FY into AST. Substitute and get the value of XU. Okay. Substitute and get XU. Note, what value of XU we get is depth of neutral axis for given section. Once again I am telling. Okay, now further note in the class. So once you get XU, I will tell you now, I am dictating now. Now is the time to decide, you write here, now is the time to decide whether cross section is under reinforced or over reinforced. Therefore, next step will be information to decide whether cross section is under reinforced or over reinforced. For that you require XU max. Therefore, I will continue now. Next step I will continue writing here. This full I am removing now. You do one thing. Take a neat screenshot of this. I will come here once if you want. Okay, see. You can pause and take a screenshot now. Okay. Take a neat screenshot. Then, second round I am giving procedure. That also take a screenshot. Then, in a book, neat handwriting with the same colors and importance, write everything. You should not refer screenshots for solving problems. When you solve a problem, you should not use screenshot. Okay, over. Now, I will continue further steps. Okay. Continue procedure. Just a note, actually not required. Now we know the value of XU. See, when I concluded last part, we got the value of XU, that is depth of neutral axis for given cross section. Actually not required. It's a reminder. Reminder only. I told last step was we got XU. Okay, now class, some note I will tell. You should write it outside the procedure or in a box you write so that don't disturb procedure. Class, now you should decide whether cross section is under reinforced or over reinforced. For that we require some property for a balanced section. Okay, write that one. Right, next step. We know the value of XU. I told you, you know the value of XU. Get the value of XU max. That is, this is also told for you. Limiting value of XU as per IS code, or see, for that XU, green color XU, it is a limiting value. Or you can tell easily next time onwards, I will use depth of neutral axis for a balanced section. For a balanced section. Okay, for a balanced section. Okay. How to get it? You already know XU max by D. You know the value of D. So XU max equal to whatever value you got, multiply by D. That I should not tell first of all. Okay. Get XU max. Next step. Compare, most important, compare XU with the XU max. That is depth of neutral axis. Never compare XU max with XU. Some people they compare reverse way. No. For avoiding confusion, compare the depth of neutral axis for a given section. Whatever XU you calculated with limiting value, XU max. Depth of neutral for given section, for balanced section. Two cases are possible. You write here. You can write here. One note you can write here. Note. Now, two cases are possible. Case 1, XU less than XU max. Case 2, XU more than XU max. Somebody will tell, sir, if it comes equal, it will never come equal. In my entire teaching so far, spanning around 40 years, it never came. If it comes what? Why problem? If it comes equal, then case 1, case 2, both you can apply. What you do for case 1 is applicable for case 2 also. So you can write here XU less than XU max or even equal to XU max. You can write that way also. Even equal also will do. It will not come. Okay. Then cross section is under reinforced. Class, I already told last time procedure underlying post section, you can find ultimate MR by either CU into liver arm or TU into liver arm, even though working test method, you cannot do that way. You can do it here. See, working test method outside the procedure. If you use CU, actually you have to use TU into A with full strength of steel. If you use CU into A, stress in concrete to be reduced. Limit state, no. As I told, beautiful concept. I told last class, star mark. When I get at least, you go to last class, I told, I will take exclusively one class for that one. And one more concept is there. See, one personal note is there. This also I will tell in that class. Provided I get request by at least 100 people. I told last time I told in the comment box, if I get request by at least 100 people, unknown people, one commented today, he's a known person, I'm not considering. He is already in the group. He commented, sir, I want explanation for star. When he come to the class, I will tell, don't comment. For you already explained. For them it is already explained. Okay. Now, write all the note. Now, come here. Procedure. Find MR. If XU comes less than XU max, under post section, you can find MU either by CU into A or MU either by TU into A. Okay. If you use MU equal to CU into A, remember, basic equation is MU equal to 0.36 FCK BXU into D minus 0.42 XU. Or IS code version, what they done? They took D out, they took this D outside, then where you get D outside, see 0.36 into, or I already told last time, this is basic equation, or same equation, IS code, they gave this way, both are same. 0.36 XU by D into 1 minus 0.4 XU by D, I prefer this equation. Okay. This is based on CU into A, or based on TU into A. Basic equation. This all I told yesterday. MU equal to 0.87 FY into AST into D minus 0.42 XU. And or if you use IS code version, 0.87 FY AST D into 1 minus AST FY by BDFCK. But one note you are right. IS code what they done is, they took D outside here, then XU by D, they used 0.87 FY into AST divided by 0.36 FCKBD, then you got 0.42 into 0.87 by 0.36. It comes to 1.005. They rounded to 1. Therefore, if you use this equation or this equation, there will be slight variation. Make a note. Because 1 minus, it is actually not, see, it is 1 minus 1.005 into further terms. So, for the second term, you have to multiply with 1.015. But IS code decided, a very small value, leave it. Not small value, almost, after 1, that 0.015, they ignored. Therefore, right here, this and this expression will give slight difference. Okay, no problem. Okay, over. Now, before that, one more thing required. Nodi means Kannada. Okay, leave it. You write here, XU less than XU max. Cross section is under input. Immediately, before proceeding further, you make a personal note. See, personal note. I will tell at the end of the class. Make a special note, which is a personal note. XU comes less than XU max. Remember, in this is for entire limit state method. This is for entire limit state method. XU came less than XU max. When XU is less than XU max, XU will remain as it is. Means whatever you calculated, it will remain as it is. Remember, XU max, see XU, if it is less than XU max, whatever you calculate XU, that will remain as it is. Those who are in the group, I told there, less means less, equal means equal, but more means, I told them, I'll tell you later. Okay, make this note. Now, find ultimate MR for under post. Now I will go to case 2. Okay, case 2 will be, see, case, 1 minute, case 1, safer side. Take a screenshot. Okay, I'll come this side. Pause and you pause it, Take a screenshot now. Right. Case 2. I will try to here. Case 2. XU is more than XU max. Dangerous one. More. Cross section is, if your XU comes more than XU max, cross section is what? Over reinforced. It is over reinforced. I forgot last time. You can write one small note there. When you got under reinforced, you write that is primary tension failure good, recommended by IS code. Now write primary compression failure bad, IS code is not recommending it, or they do not want that one. Okay, start. Now, over reinforced. Then make a special note. I will tell you special note now, and these all I will change. Okay, I will change all this now, but before that one, I want little time for removing this left side part. I will remove the left side part. Some note I have to give for over reinforced section. Some special notes are there. 1 minute. Start now. Case 2. Oh, I forgot to write U there. Actually not understood. XU has got a U. Okay, okay. Done. Case 2. XU more than XU max. Right. Cross section is over reinforced. Okay, then class. Prepare a personal note. Prepare a personal note. Okay. It is here. See. Personal note is here. This is a personal note you prepare. That is, when XU is more than XU max, XU calculated gets cancelled. Instead, take XU equal to XU max. Or last I will tell. Okay. Now, one statement I will write here. As per IS code, a cross section should, one more thing, you write there. Over reinforced, primary compression failure, dangerous. Why? I told, or star class I will tell. If at all I conduct the star class, requirement I told you. As per IS code, a cross section should never be designed as over reinforced. In such a case, during design I told, cross section should be redesigned. How? In the design case, I will cover in the group, not for you. Okay, now, however, but right now, we are not doing design. We are analyzing the given cross section. Therefore, however, in case of analysis, if cross section is found to be over reinforced, that is when XU comes more than XU maximum, then ultimate MR of that cross section is limited to that of a balanced section. Means you should not take the strength of that cross section beyond the balanced section. Actually, strength will come more. Extra strength not considered. Or you can tell that is for XU equal to XU max. Therefore, if XU is more than XU max, consider XU equal to XU max to find ultimate MR of cross section MU, or for a balanced section IS code, they told this as MU limit. Why? It is a limit. So, ultimate MR of a singly imposed rectangular balanced section, IS code used the word MU limit. Because beyond that, you cannot consider. Okay, now, how to find? Okay, now, important. Find MU by CU into A. Very, very important. CU into A. And what you do? Replace, substitute what? XU equal to XU max. Substitute XU equal to XU max. I told you already. Substituting XU equal, already told, XU equal to XU max. Remember, CU into A. CU into A. By CU into A. Okay, now find MU by CU into A. Do not go for MU equal to TU into A. 1 minute. I will explain little later. What is the problem? I will explain. Okay, now, so you use CU into A. Do not go for TU into A. Let me complete that one. Then I will give the note for you. Okay, I will rub here only. It's a wasting time. I will remove here only now and write. I don't want to. It's okay. See now. Remember, find mu by Cu into A. That is mu equal to 0.36 FCK into B into XU. This time, 1 minute now, I'll use XU this way. Not that value XU cancelled. XU into D minus 0.42 XU. This is the basic equation. This is the basic equation. Of course, remember, XU equal to what? Replace XU by XU max. Why? I told just now, if XU comes more you cannot take. Take equal. This is the basic. Or IS code version. Mu equal to mu equal to 0.36 into XU by D into 1 minus 0.42 XU by D into BD square into FCK. This is IS code version. Here, what you do? Substitute XU equal to XU max. Or you can tell XU by D equal to XU max by D. Then, when this XU by D becomes XU max by D, then in IS code, that mu is called, see there, mu limit. When mu limit, when XU by D reaches XU max by D, it is called mu limit. Now, this is expression for mu. Consider only Cu into A. Now, I will write something here. Then I terminate. Next class I will give example. Danger. Better not go for go for mu equal to Tu into A. Better not go. Use Cu into A. Under reinforce you can use anything. Now, it is not that we cannot use mu equal to Tu into A. Possible, but there are some precautions or corrections or concepts, whatever you want, concepts are there. Anyway, in class, when I consider numerical example, I will calculate mu by mu equal to Tu into A with the applicable corrections or precautions. I will tell. Right now, make a note, do not consider. Over reinforced section, never consider mu in terms of tension. See why? Because area of steel provided is more than that balance section. Under reinforced, either Cu into A or Tu into A. But over reinforced, only Cu into A. Do not consider Tu into A. But I will consider it as a special note. Or I will take one more extra class for that one. Okay. Now, one last note right here. But this is more I will tell in the star class if I conduct. Now remember why star class is more and more important. See, in the regular group, I have given a money matter example there. If I conduct the star class, beautiful money matter example. I will tell the money matter example also there, provided I take the star class. Conditional I told. Minimum 100 requirements. Okay. This is for, see, entire limit state method. Entire limit state method means singly reinforced, doubly reinforced or T section, any section. Less means less. Right here. Less means less. Or less means what? Less means as it is. Less means less. Or again red color is coming. Less means less. That is as it is. That is as it is. That is whatever you got, XU, use the same XU. Equal means equal. What is this one? Someone will be laughing. Equal means equal. It will never come. But more means not more, equal. So if you get more, cancel right here. If you get more, which one? XU. Cancel the more, take equal. Money matter is very ideal there. Okay, start. Now we are ready for performing numericals. I will explain further slowly in the numerical. Very slowly. I will take my own time so that everything clear. So this complete procedure you have to write and neatly in a book you have to write. Then subsequently solve the numericals where write all the explanation I tell in the class. See you in next part. This is part 3 I think most probably. Next is part 4. Okay, thank you.